And now for the exciting conclusion of Chapter 4, Quadratic Equations. It's exciting because I think you'll agree, I hope you agree, that given the last section on completing the square, absolutely any quadratic equation can be solved using the completing the square method. And just to prove that to ourselves, remind ourselves of that, let's solve this quadratic equation using completing the square, just as a quick reminder. Okay, so the first thing we need is for this to be a 1, so we need to divide this by 3, so it'll be a 1, which means we have to divide everything by 3. So this will give us a 1x squared. You divide this by 3, you get 14x. You divide this by 3, you get 8. Divide 0 by 3, you get 0. Okay, so next, remember completing the square is, the key to it is having the right constant here, so that when you factor all of this, it's a perfect square. It comes out to be the same set of parentheses times itself. But that 8 right there is not the right guy for the job. So let's move it to the other side and leave a little room to find the better fit. So we'll get a negative 8 over here. And what number we're going to put here first, we'll take 14 and we'll divide it by 2. We'll find that 7, then we take 7 and we square it, that's 49. And that is the perfect number to go right there. Remember, that's completing the square right there. It's completing the square because now this will factor as x plus 7 squared. That's a perfect square. Alright, but let's not forget we've added 49 to this side. And if we add something to one side, we have to do it to the other. So let's add 49 to this side. So that'll come out to be 41. Negative 8 plus 49 is 41. We take the square root of both sides. So you get x plus 7 equals plus or minus the square root of 41. And subtract 7 from both sides. And there we go. Those are the answers. As odd as they seem, as odd as they are, those are the answers. And I think you'll agree that no matter what these numbers were, if this 3 was a 5, and this 42 was a 17, and this 24 was a negative 8, we could do the same exact process, and we would get something for the answer. Now, they may look really odd, and they may be really confusing or whatever, but it's possible. You can do it for absolutely any numbers that you want. So what we'll do with that, the cool thing, the conclusion, is since these could be anything, 3 could be anything, 42 could be changed to anything, 24 could be changed to anything, let's let that be a possibility. Just anything for A. And anything could be in there for B. And anything could be there for C. We'll let them be variables from the beginning. And we'll move these variables around, and what we'll have in the end is we'll have done all the same steps, only we'll have used variables, and we'll have x equals a bunch of stuff, A, B, and C on this side. And then once we know A, B, and C, we can just plug it in, and it'll be like all the work is done for us. The completing the square is done, and we just need to plug in A, B, and C, and then this is what would come out of it if we had this formula. And so what we're making is a quadratic formula. So let's do that. Let's put do the completing the square on this general quadratic equation, just like we did on the specific quadratic equation, and see what falls out. So the first thing we did was divide by 3. That's because we need a 1 out here, and so whatever we would, if there was anything but a 1 out here, the first thing we would have to do is divide by a. So we get x squared plus b over a times x plus c over a. Okay. And then this c over a most likely is not the perfect number, whatever it turns out to be, to make this a perfect square. So just to cover our bases, we'll subtract c over a on both sides. Okay. Equals negative c over a. What do we do? To find this number, we do the same thing as we did with 14. We take this. It's not 14, but whatever it is, we will divide it by 2. Let me just fix that. We'll divide it by 2. Now, when you're dealing with a fraction and you're saying that you want to divide by 2, it's a lot easier to instead multiply by 1/2. Okay, so that'll be b over 2a. Then we'll square that. Okay, that means multiply this fraction by itself, which means we get b times b, that's b squared, over 2a times 2a, that'll be 4a squared. So we add b squared over 4a squared. And we need to do that to both sides. Okay, so this looks like a mess, but it simplifies really easily because it factors into that perfect square. So x plus, it always turns out to be this guy whenever you divide this middle term by 2, right? Like we divided this by 2 and got 7. 7 was in the parentheses, so we get b over 2a, goes in the parentheses here. And now on this side we have b squared over 4a squared. And we could put minus c over a, but let's instead of c over a, let's get this to have a common denominator with this guy here. So in order to get a common denominator, the denominator needs to be 4a squared, so we need to multiply this by a 4 and an a in order to get 4a squared, and so we need to multiply the numerator by 4a as well. So what we wind up with is a negative 4ac, right, 4ac over 4a squared. So that means we could just we could extend this out because we have a common denominator, and so we combine them into one fraction. So b squared minus 4ac over 4a squared, and then we'll take the square root of both sides. So it's going to move this over to the left so we have a little room. X plus b over 2a equals, now let's take the square root of the numerator and denominator separately. That's something we can do by the property of square roots. Over the square root of 4ac, or 4a squared. Okay, and now we're going to subtract b over 2a from both sides. So now we've got x by itself. So we've got the square root of b squared minus 4ac over the square root of 4a squared. Now the square root of 4a squared is the square root of 4, which is 2, times the square root of a squared, which is a. And now we're subtracting b over 2a. 2a. Okay. Well, you'll notice this is a fraction, this is a fraction. They both have the same denominator, so we can put them together. So we could do square root of b squared minus 4ac, and then subtract b, and that'll all over be b all over 2a. But we're just going to change the order a little bit. Rather than taking the square root and subtracting b, we'll write it like this. Negative b. We should have been writing plus or minus here. Plus or minus. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So that is it. Notice all we did was take a general quadratic equation, apply the same steps as we did to the specific one, apply the same steps to that general quadratic equation, and what we have in the end is x is by itself. All you need to know is a, b, and c. You plug them into the quadratic formula, and you'll know the answers. All of that, completing the square, all those steps have been done, all the work has been carried out, all the the heavy lifting is over with, and what we have left is the quadratic formula. And so we'll work out some examples in the sample problems video as to how to use it. But there it is, we derived it, and if you followed along you should be proud, and you'll be better in better shape to understand all these new things as they unfold throughout the year. So hope that was helpful. Thanks for watching.